Good morning all of you. I completed the numericals on stopping side distance in the last session. Okay. Today I'll proceeding with the next topic, that is overtaking side distance. Overtaking side distance, OSD. Okay. What do you mean by overtaking side distance? Okay, there are two definitions for overtaking side distance. The first one, it is the overtaking side distance is the minimum distance available for a driver of a vehicle intending to overtake slow moving vehicle ahead with safety against the traffic of opposite direction. Is it clear? The minimum distance available for a driver of a vehicle intending to overtake slow moving vehicle ahead with safety against the traffic of opposite direction, that is the overtaking side distance. Okay, another definition is the distance measured along the center of the road which a driver with his eye level 1.2 meter above the road surface can see the top of an object 1.2 meter above the road surface. Means both the driver's eye level above the road surface 1.2 meter and as well as the object above the road surface also 1.2 meter. But in case of your stopping side distance, okay, the driver's eye level above the road surface 1.2 meter and object height above the road surface it is 0.15 meter. But here both eye level of the driver and object above the road surface it is 1.2 meter only. Is it clear? Next, factors on which OSD, overtaking side distance, depends. Factors on which overtaking side distance depends. Okay, the first factor, it is speeds of number 1 overtaking vehicle, okay, number 2 it is overtaken vehicle, and number 3 it is vehicle coming from opposite direction, if any, coming from opposite direction if any. Okay, the first factor, it is speeds of overtaking vehicle, speeds of overtaken vehicle and speed of vehicle coming from the opposite direction, if any. And the second factor, it is distance between overtaking vehicle and overtaken vehicle. The distance between overtaking vehicle and overtaken vehicle. The minimum spacing between the overtaken vehicle and overtaking vehicle depends on the speed of vehicles. Okay. Third factor, it is skill and reaction time of the driver. Fourth one, it is rate of acceleration of overtaking vehicle. And fifth one, it is gradient of the road, if any. gradient of the road if any. Okay, these are the 5 factors on which the overtaking side distances depends. The first one, it is speeds of overtaking vehicle, overtaken vehicle, vehicle coming from the opposite direction if any. Second one, it is distance between the overtaking vehicle and overtaken vehicle, and we know that the minimum distance between the overtaking vehicle and the overtaken vehicle depends on speed of vehicles. And third one, it is skill and reaction time of the driver. Fourth one, it is rate of acceleration of the vehicle to the overtaking vehicle, rate of acceleration of overtaking vehicle. And fifth one, it is gradient of the road if any, gradient of the road if any. Okay, these are the 5 factors on which the overtaking side distance depends. Is it clear? Okay, next I'll move on to the analysis of overtaking side distance. Analysis of overtaking side distance on two-way road, on two-way road. Okay. Okay, this figure shows the overtaking maneuver, that is overtaking operation. Let A is the overtaking vehicle and B is the overtaken vehicle and C is the vehicle coming from the opposite direction. Let A is the overtaking vehicle moving with the design speed of V meter per second and B is the overtaken vehicle moving at the speed of VB meter per second and C is the vehicle coming from the opposite direction and moving at the design speed V meter per second. Is it clear? And this shows the overtaking maneuver. Is it clear? And it's very simple to analyze the overtaking side distance on two-way road. Okay, see here, for calculation purpose of overtaking side distance, the overtaking operation split up into three operations, that is D1, D2, D3. D1, D2, D3. Okay, what are the D1, D2, D3? It's very simple. Observe in the figure. D1 is the distance travelled by A from position A1 to A2, from position A1 to A2. D1 is the distance travelled by the overtaking vehicle A from position A1 to A2. What will happen? The overtaking vehicle A, okay, initially moving at the design speed V meter per second, but forcibly reduce its speed to VB meter per second, that is the speed of overtaken vehicle. Okay, the overtaking vehicle has forcibly reduced its speed to the speed of overtaken vehicle, that is VB meter per second, because to maintain the minimum spacing between the overtaken vehicle and overtaking vehicle. Okay, see here, where S is the spacing between the overtaken vehicle and overtaking vehicle and B is the distance travelled by the overtaken vehicle during overtaking operation. Okay, is maintaining the spacing S and also waiting for the better opportunity to overtaking the slow moving vehicle B. Okay, but the thing is that when the vehicle reduce its speed to VB per meter per second, then it's moving at certain distance with the same speed. Okay, for maintaining a sufficient spacing between the overtaken vehicle and overtaken vehicle, that distance covered by using by travelling at the speed of VB per meter per second during the reaction time t seconds, that is the D1. Okay, D1 is the distance travelled by the overtaken vehicle during the reaction time t seconds. During the reaction time t seconds, that is the distance D1. Okay, and we know that for the distance travelled by vehicle is equal to product of speed and time. Okay, then D1 is equal to VB multiplied by T meter, where T is the reaction time of the driver and VB is the speed of the overtaken vehicle. But why? Here the vehicle is moving certain distance, okay, that is the D1, no? Why you are using VB here? Because the vehicle A also reduce its speed to the speed of vehicle B, because it has to waiting for the better opportunity to overtake the slow moving vehicle, no? Okay, for that it reduces its speed to VB and the vehicle A moving with that speed only, VB, for a certain distance to maintain the spacing between A and B. Is it clear? Okay, then see here, from position to A1 to A2, okay, the vehicle A travelling at the speed of VB meter per second during the reaction time t seconds. During the reaction time t seconds, we know that reaction time, no? Okay, in the stopping side distance, the reaction time of the driver, it is 2.5 seconds. For calculating the stopping side distance, IRC has suggested the reaction time of the driver 2.5 seconds, but for the overtaking side distance, Indian Roads Congress IRC suggested the average reaction time of the driver, it is 2 seconds. 2.5 seconds for stopping side distance, it is 2 seconds for overtaking side distance. Means D1 is the distance travelled by the overtaking vehicle during the reaction time t seconds. Therefore, D1 is equal to Vb into t. We know that the distance is equal to the product of speed and time. Okay, the speed is Vb and time is reaction time t seconds. Okay, we get the answer in terms of meter. Then D2, the second operation is D2. Okay, when the vehicles A, that is the overtaking vehicle, during the reaction time comes to a position of A2, from A1 to A2, okay, and the vehicle moving at the Vb meter per second only, the overtaking vehicle moving at the Vb meter per second only, and it is waiting for better opportunity, and when it gets opportunity to overtake the slow moving vehicle B, the vehicle A, that is overtaking vehicle, shift to the adjoining lane, and overtake the slow moving vehicle and then shift back to the original lane. Okay, when he gets an opportunity to overtake the slow moving vehicle, he shifts the adjoining lane, okay, and overtake the slow moving vehicle and shift back to the original lane ahead of slow moving vehicle. Shift back to the original lane ahead of slow moving vehicle and allowing the same minimum spacing S between the overtaking vehicle and overtaken vehicle. And keep it in mind that while overtaking the slow moving vehicle, okay, you should care against the traffic of opposite direction. Okay, without colliding with the traffic of opposite direction, okay, he has to overtake the slow moving vehicle, okay, safely. Is it clear? Means from position A2, the overtaking vehicle waiting for a better opportunity to overtake the slow moving vehicle B. When he gets an opportunity, the vehicle A accelerates his vehicle. The driver of the vehicle A accelerates his vehicle and shift to the adjoining lane and overtake the slow moving vehicle B and shift back to the original lane ahead to the slow moving vehicle. And maintaining the same spacing S, and in this course of time, that means the duration of overtaking time, during the course of overtaking time, the slow moving vehicle B travels from position B1 to B2. Okay, the distance covered by the slow moving vehicle from position B1 to B2 during the overtaking operation time, that is overtaking time, okay, that distance is B. Means when he starts, the vehicle A starts overtaking the slow moving vehicle, okay, and shift back to the original lane. For that it takes some time, no? That is the overtaking time. Usually the overtaking time is denoted by capital T. Capital T means during the capital T seconds, the slow moving vehicle B, okay, changes its position from B1 to B2. Means the distance travelled by the slow moving vehicle from B1 to B2, that is B. And S is the spacing between overtaking vehicle and overtaken vehicle. Here the spacing between A2 and B1 is S. Similarly, the spacing between B2 and A3 is S. Is it clear? Then what is D2? The D2 is the distance travelled by the overtaking vehicle A from position A2 to A3. From position A2 to A3 during the actual overtaking operation, means during time t seconds, capital T seconds, where capital T is the time took for overtaking. Time took for overtaking means the vehicle changes its position from A2 to A3, okay, whatever the distance covered by the vehicle A to change its position from A2 to the A3, that distance is D2. That distance is D2. And you may also observe here that D2 is split up into three parts. The D2 is split up into three parts, that is S plus B plus S. S plus B plus S. What is S? It is the spacing between A2 and B1. And what is B? It is the distance travelled by the slow moving vehicle B from position B1 to B2. And what is S again? It is the distance, that is the spacing between B2 and A3. Spacing between B2 and A3. Then your D2 is equal to S plus B plus S. S plus B plus S. Okay. Then D2 is distance travelled by A, vehicle A. A is the overtaking vehicle from position A2 to A3. It is D2 is equal to S plus B plus S. We can write this, okay, B plus 2S. B plus 2S meter. B plus 2S meter. Is it clear? Okay. And we know that B is the distance travelled by the slow moving vehicle from the position B1 to B2. Okay. And we know that distance travelled by any vehicle is equal to speed multiplied time. Is a product of speed and time. The distance is the product of speed and time. What is the speed of slow moving vehicle? That is VB meter per second. And what is the time to change the position from B1 to B2? The actual overtaking operation time, that is capital T seconds. Then your VB is equal to distance travelled by the slow moving vehicle from B1 to B2, that is B is equal to VB into T. The distance is the product of speed and time. No, actual time took for change the position from B1 to B2 is the overtaking time. Okay, means when the vehicle changes its position from A2 to A3, okay, during that time itself the slow vehicle changes its position from B1 to B2. No, means the same time, that is capital T seconds, the overtaking time. Then B is equal to VB into T. B is equal to VB into T. Then it becomes, therefore D2 is equal to VB into capital T plus 2S. Okay, and where S is the spacing between the overtaking vehicle and overtaken vehicle, and the S, okay, you can get it from the empirical formula, that is 0.7 VB plus 6. Okay, where S is 0.7 VB plus 6, where S is equal to 0.7 VB plus 6. It is an empirical formula. So we can get the answer in terms of meter, spacing between overtaking vehicle and overtaken vehicle. Okay, and T is the overtaking time, the time took for actual overtaking in terms of seconds. Is it clear? And to get the value of T, okay, means what is the time took for actual overtaking? What is the time took for actual overtaking means what is the value of capital T? Okay, we get the S in terms of empirical formula, that is 0.7 VB plus 6. Then what about T? Capital T seconds. Usually the capital T, that is the overtaking time, you may get it from equating the D2 to the distance travelled by the uniformly accelerated body. Okay, we know that the distance travelled by the uniformly accelerated body is equal to V into T plus half AT square. Vt plus half AT square is the distance travelled by the uniformly accelerated body. Okay, then equating this D2 to that distance travelled by the uniformly accelerated body, then we get the value of t. Is it clear? Okay, go for that. d2 is equal to what is that? Vb into capital T plus 2s. That is equal to Vb into T plus half at square, that is at square by 2. Half at square, that is at square by 2. Half at square by 2, no? Okay. So Vb is the distance, that is the speed of the vehicle, uniform speed, and A is the average acceleration of the overtaking vehicle. And keep it in mind that the overtaking time capital T is depends on the speed of slow moving vehicle Vb and the acceleration of the overtaking vehicle A. Okay, the T depends on overtaken vehicle speed, that is Vb, and overtaking vehicle acceleration. Okay, in this Vb get cancelled, then remaining is 2s is equal to half at square. 2s is equal to at square by 2. Then your t is equal to root of 4s by a. Then your t is equal to root of 4s by a. Therefore, t is equal to root of 4s by a, where s is the spacing between overtaking and overtaken vehicles, and a is the average acceleration of overtaking vehicle in terms of meter per second square. Okay, average acceleration of overtaking vehicle A in terms of meter per second square. Okay, this is regarding the second operation d2, distance travelled by the overtaking vehicle A from position A2 to A3. Okay, then d2 is equal to what? Vbt plus 2s. d2 is equal to Vbt plus 2s, where t is the overtaking time, that is equal to root of 4s by a, and s is the spacing between overtaken vehicle and overtaking vehicle, that is equal to 0.7 Vb plus 6 meter. Okay, this is regarding the second operation. Okay, next we'll move to third operation d3. Third operation d3. See here, d3 is the distance travelled by the vehicle C from position C1 to C2. Distance travelled by the opposite coming vehicle, that is oncoming vehicle, we can say opposite coming vehicle, the vehicle coming from opposite direction, we can say that oncoming vehicle. Okay, the distance travelled by the oncoming vehicle C from position C1 to C2, that is d3. Okay, and the vehicle C changes its position from C1 to C2 during the actual overtaking operation. During the actual overtaking operation means when the vehicle A changes its position from A2 to A3, okay, during the time itself the vehicle C changes its position from C1 to C2, means whatever the time taken by the vehicle A, okay, to change its position from A2 to A3, the same time will took by vehicle C to change the position from C1 to C2, and it is travelling at the design speed. It is travelling at the design speed V meter per second. Then we know that distance is the product of speed and time. Okay, the speed is V and time is the actual overtaking time, capital T. V into T will gives d3. Okay, d3 is what? Distance travelled by the oncoming vehicle, that is vehicle coming from opposite direction, oncoming vehicle C from position C1 to C2, from position C1 to C2. Therefore, d3 is equal to V into capital T meter. V into capital T meter. Is it clear? Okay, where V is the design speed in terms of meter per second, T is the overtaking time. Okay, the time took for overtaking operation, overtaking time in terms of second, that is equal to root of 4s by a. Okay, don't confuse with the small t and capital T. Small t is the reaction time of the driver. Usually for calculation purpose of overtaking side distance it is 2 seconds. Okay, but for stopping side distance it is 2.5 seconds. Okay, and capital T is the time took for actual overtaking, that is overtaking time. That is in terms of second, that is equal to root of 4s by a. Okay, then for a two-way traffic on two-lane road, the overtaking side distance is the sum of d1, d2 and d3. Okay, if it is one-way traffic on two-lane road, then there is no matter of d3. There is no matter of d3, only sum of d1 plus d2 will give the overtaking side distance for a one-way traffic on two-lane road. And here kept in mind that it is only possible to overtake the vehicle when it is two-lane road. Okay, for single lane road is not possible to overtake because it has shift to the adjoining lane. No, when the lane width is more, then only it is possible to overtaking the slow moving vehicle. Okay, and this is the overtaking maneuver or overtaking operation for two-way traffic on a two-lane road. Okay, for that the overtaking side distance OST is equal to d1 plus d2 plus d3. This is the overtaking side distance for two-way traffic on two-lane road. But if it is one-way traffic on two-lane road, then it is d1 plus d2 only. Okay, what is d1? It is Vb into small t. Vb into small t, then what is d2? Then it is Vb into capital T plus 2s, Vb into capital T plus 2s, and d3 is equal to V into T, d3 is equal to V into T. Okay, where T is capital T is the overtaking time, that is equal to root of 4s by a, and s is the spacing between overtaken vehicle and overtaking vehicle. Okay, that is usually 0.7 Vb plus 6. Okay, this is regarding the analysis of overtaking side distance on a two-way road. Okay,